Welcome to the deep dive. Today we're going straight into a really critical area for anyone involved with helicopters.
Yeah, keeping things safe on the ground.
Exactly. And making sure everything's sorted before we even think about taking off. We've got a very focused look at this today.
It's based on a whole chapter dealing with helicopter ground procedures and flight preparations.
Right. So think of this as your kind of insider's briefing on making sure these machines operate safely, from touchdown all the way back to takeoff.
Precisely. And it's not just about ticking boxes, is it? It's about building a real safety mindset.
A culture, almost.
Yeah, a safety culture around every single ground operation. The piloting command, well, they carry a huge responsibility.
From the absolute beginning, the walk around.
Right through to shutting down afterwards. Our goal today really is to dig into those essential elements.
So everyone listening gets a clear picture of what's needed for solid ground safety. Okay, let's get right to it then. The foundation has got to be the pre-flight inspection, making sure the helicopter is actually airworthy.
Absolutely.
Our source material couldn't be clear on this. The pilot in command, the PIC, is ultimately the one on the hook.
Always. For ensuring that helicopter is airworthy before every single flight. No exceptions.
And there's a helpful image in the material, figure 8.1, it shows a pilot, carefully going through a checklist.
That picture really nails the importance of being systematic. The information we have really stresses how vital it is to use the checklist.
The ones that come from the official sources, right?
Yeah, the rotorcraft flight manual, the POH, or sometimes manufacturer or operator-specific lists.
These aren't just like suggestions, are they?
Not at all. They are essential tools. They're designed specifically to ensure every critical component.
Even the extra stuff.
Yeah, even supplemental equipment that's been added gets a thorough check. The manufacturer put those items on the list for, well, very good reasons.
Makes sense.
Sometimes it's the things that seem less obvious on those lists that can actually cause the biggest problems if they're missed.
Absolutely. It's all about catching potential issues while you're still firmly on the ground.
Not finding out about them midair.
Definitely not. Okay, so what happens if during this detailed pre-flight, or maybe even before you head out to the aircraft, you find something that's, well, not working?
Ah, right. Inoperative equipment.
Our source gets right into this.
Yeah.
Lays out a pretty firm general rule based on 14 CFR.
Which basically says all aircraft instruments and equipment need to be working before you fly. That's the default.
That's the starting point.
That's the standard, yeah. But, aviation understands that things happen. Equipment can fail.
So the information introduces us to the two main ways a pilot operating under Part 91 can legally fly with certain non-essential gear that might be broken.
The first is the deferral provision. That's in 14 CFR section 91.213D.
Okay.
And the second is using an FAA-approved minimum equipment list or mail bell.
All right, MEL. Okay, let's break down that first one then, the deferral provision. 91.213 time. Our source says it's popular.
Yeah, mainly because it's relatively straightforward. Less paperwork involved, generally.
So say you find something isn't working and your helicopter doesn't have an MEL. What's the process?
Okay, the crucial thing here, and the material really highlights this, is for the pilot to figure out if that broken piece of equipment is actually required.
Required by what?
Either by the helicopter's original type design certificate or by a specific rule in 14 CFR.
Okay.
If it's determined that the item isn't needed for safe flight, and importantly, you can still operate the helicopter safely without it,
Then you can defer fixing it.
then you can defer it, yes.
Yeah.
But, and this is important, there are specific steps you absolutely have to take.
Right. And those steps, our source details them. It includes either deactivating the item
Like pulling a circuit breaker, maybe?
or even physically removing it.
Yes. But removal, the source is very clear. That always needs to be done by certified maintenance personnel. You can't just start taking bits off.
Gotcha. And then, this seems key, placing a clear inoperative placard right there.
Right near the switch, or the control, or the indicator for that item. It has to be obvious.
Yeah, makes sense.
The source gives a pretty good example, actually. Inoperative position lights on a daytime VFR flight.
Okay.
The pilot has to think ahead. Is there any chance this flight might run into nighttime hours? Because then those lights would be required.
So it's about assessing the specific flight you're planning.
Exactly, thinking through the actual impact. And remember, even a simple deactivation like pulling and collaring a breaker needs that placard.
And anything more involved.
Definitely needs certified maintenance to handle the deactivation properly.
Okay. Now, let's shift to the other main way. The minimum equipment list, the MEL.
Right.
Our source explains this is more formal. It's a pre-approved process.
Yeah, the operator has to actually request an MEL for a specific aircraft serial number.
And the FAA has to approve it.
Yes, and if they do, they issue what's called a letter of authorization, an LOA.
And here's where it gets interesting once you have an approved MEL for that helicopter.
Using it becomes mandatory. That's a critical difference from the deferral rule.
Mandatory. Okay, so if you have an MEL, you have to use it for deferrals.
Correct. Any decision about deferring maintenance has to strictly follow what the MEL says, its terms and conditions.
And the operator's own procedures, too.
Yes, and the operator's procedures document which accompanies the MEL. The info we have breaks down how an MEL is actually put together.
It starts with the master MEL, the MAL.
Right. The FAA's Master Minimum Equipment List provides the basis. Then you add the LOA, a preamble section explaining how to use it, and those operator-generated procedures.
And all of that has to be on board.
All those documents have to be readily available on the helicopter.
And the source mentions something interesting. An approved MEL is considered a supplemental type certificate, an STC.
It is, yeah.
So what does that mean in simple terms? Like, why is it an STC?
It basically means the FAA is formally signing off on operating that specific aircraft in a condition that might differ slightly from its original type certification.
Ah, okay. Because some equipment might be allowed to be inoperative.
Exactly. But it's approved under the specific conditions laid out in the MEL. So going back to our position lights example,
Right.
if the helicopter has an MEL, the pilot wouldn't use the general 91.213D rule. They look up position lights in their specific MEL.
And the MEL would say if daytime flight is okay without them.
Precisely. And if it is allowed, the MEL would also spell out exactly what needs to be done.
Like logging it.
Right, making an entry in the maintenance log, deactivating the lights according to the approved procedure in their ML supplement.
Yeah, the placard, of course.
And, of course, placarding the switch inoperative. It gets a very specific pre-approved pathway.
Okay, but our source also makes it clear. MELs have limits too, right? You can't defer everything.
Oh, absolutely not. Certain really critical components, things that are not listed as deferrable in the ML, things like, say, the main rotor tachometer, the engine tachometer, maybe the cyclic trim system, those kinds of essential items.
They have to be fixed.
They absolutely have to be repaired before the helicopter can fly. No deferrals allowed for those.
Makes sense. They're pretty fundamental.
Exactly. These are typically items considered essential for safe flight, no matter the conditions.
Now, the information mentions another possibility. What if the helicopter isn't airworthy, but it is safe enough for a specific flight?
Ah, yes. You might be able to get a special flight permit, sometimes called a ferry permit.
From who?
From the local FAA Flight Standards District Office, the FSDO. This permit could allow you to fly the helicopter, even though it's technically not airworthy.
But only for a specific purpose.
Right. Typically, to fly it to a location where the necessary maintenance or repairs can be done, it has to be safe for that specific flight, though.
That sounds like a really useful option sometimes. But the source adds a strong note of caution here, doesn't it? About deferring maintenance in general.
It does. It really stresses that deferring maintenance shouldn't be taken lightly.
You have to really think about the impact.
Yes. Carefully consider how that inoperative component might affect the helicopter's overall operation, especially if you have more than one thing that isn't working.
Multiple issues could compound things.
Definitely. And the source points people to Advisory Circular 9167 for more in-depth guidance on this.
Good resource to know.
Absolutely. It boils down to a proper risk assessment. Just because you can technically defer something
Doesn't always mean you should.
Exactly. Especially if it might interact with other issues or just reduce your overall safety margins.
Okay, moving on from pre-flight checks and maintenance issues. Let's talk about actually getting the helicopter ready to fly. Engine start, rotor engagement.
Critical phases.
The source details these and really hammers home how essential it is to use the manufacturer's checklists.
Absolutely. For engine start, for rotor engagement, and for the system's ground checks that follow.
Those checklists are there for a reason, right?
A very specific reason. They make sure all the necessary steps are followed in the right order and that any potential problems get spotted.
And dealt with before you proceed.
Before you go any further. And the information makes a really crucial point here.
Clearing the area.
Making absolutely sure the entire area around and above the helicopter is completely clear.
People, equipment, everything.
Everything. Before you even think about starting the engine or engaging those rotors, even experienced pilots can sometimes get a bit complacent.
Yeah, you can see how that might happen.
But these checks, they're just a vital safety net. Can't skip them.
Seems like common sense, but definitely worth stressing. And there's also a specific tip for helicopters with two-bladed systems.
Ah, yeah. Positioning the blades so they're perpendicular to the fuselage before you start the engine.
That's the reason for that.
It actually serves a couple of purposes. First, it helps prevent accidentally trying to engage the rotors if they were somehow still tied down or secured. And second, having them out to the sides makes them much more visible from the cockpit, gives the pilot a clear visual check of their orientation before they start spinning.
Ah, maximizing awareness. Got it.
It's all about that.
Okay, now we get into a section that really highlights the unique dangers associated with helicopters. Rotor safety.
Yes, extremely important.
Our source emphasizes the inherent danger of those exposed main and tail rotors. Calls for extreme caution whenever they're turning.
And there's another illustration, figure 8.2, showing safe hovering distances near obstacles.
Which can be hard to judge, right?
That figure is a great visual reminder of just how tricky it can be to accurately judge the clearance between those fast-moving rotor tips and anything nearby.
Hangars, other aircraft.
Ground equipment, people,
Yeah.
anything. And the source also points out something important. On some helicopter models, you actually can't even see the tail rotor from the cabin.
Really? Okay, that makes things harder.
It does. It makes maneuvering, especially hovering backwards or doing turns on the ground, particularly risky, requires extra visual checks and just heightened awareness.
And it's not just about hitting things. The rotor thrust itself is a hazard.
Oh, absolutely. That powerful downwash. It can kick up sand, dust, snow, ice, water.
At high speeds.
Really high velocities.
Right.
Potentially causing injuries, damaging property nearby, and drastically cutting down visibility.
Plus the danger of debris being sucked in.
Yes, FOD, foreign object debris. Anything loose on the ground can get ingested into the engine or struck by the blades. That's a serious risk.
Yeah, you hear about FOD causing engine damage.
It can lead to significant damage, even complete engine failure in worst-case scenarios. Something as simple as a forgotten tool or even loose gravel can be incredibly dangerous.
Okay, let's shift gears to another essential ground operation. Servicing, specifically refueling.
Right.
The standard procedure, according to our source, pretty straightforward. Rotors stopped completely.
Always the safest way.
And both the helicopter and the refueling unit need to be properly grounded. Static electricity risks.
Exactly. That grounding is critical to prevent static buildup, which could ignite fuel vapors. Big fire hazard.
And it's the pilot's job, their responsibility, to make absolutely sure the correct fuel grade is going in.
And any required additives, too. Using the wrong fuel can obviously be catastrophic for the engine.
Now, the source then gets into hot refueling.
Refueling with the rotors turning.
Which sounds efficient? Maybe. But the source immediately flags it as potentially hazardous.
Very hazardous if not done correctly following strict procedures.
It stresses that pilots must stay at the controls the whole time during a hot refuel.
Absolutely. And the refueling personnel, they need to be completely knowledgeable about that specific helicopter model.
And briefed on the procedures.
Thoroughly briefed. Normal procedures, communication signals, and critically emergency procedures specific to that aircraft.
The pilot might even need to train the ground crew.
Sometimes, yes. Especially if the crew isn't familiar with that particular helicopter type or hot refueling in general. The pilot's vigilance is key.
Ready to shut down instantly if needed.
Ready to shut down the engine and get out safely if anything goes wrong. The source even mentions accidents have happened because refueling personnel weren't properly trained.
Wow.
It's a high-risk operation.
And other considerations for hot refueling. For positioning the fuel truck.
Yeah, making sure the refueling vehicles are positioned well clear of the rotor arc. Plenty of clearance.
And keeping people away.
All non-essential personnel must stay well clear. And it should go without saying, but absolutely no smoking anywhere near the operation, hot or cold refueling.
Right. Now, what if the pilot has to step away briefly during refueling? Is that ever allowed?
The source addresses this specific and generally discouraged situation if it's absolutely necessary.
What's the procedure?
The procedure is engine power reduced to flight idle and then firmly apply friction locks to all the flight controls to prevent any movement.
And the pilot needs training for that, too.
Yes, the pilot must be properly trained and proficient in that specific procedure. It really underscores the danger of leaving the controls unattended with the engine running.
Definitely seems risky. Okay, let's talk about people safety now. passengers, ground crew.
Crucial area.
Our source points out, sadly, injuries, even fatalities have occurred just because people weren't aware of or didn't follow the right procedures for getting on or off.
There's another figure, 8.3, illustrating safe approach and departure paths.
And that figure really reinforces the message. Everyone needs to be constantly aware of the hazards.
And know exactly how to avoid them. The safest method, as the material states, is always rotors stopped before anyone moves near the helicopter.
But that's not always practical.
No. Given helicopter operations, sometimes rotors turning operations are necessary. So when that happens, it's vital everyone is properly briefed.
And that briefing responsibility often falls on ramp attendants, servicing personnel.
Yes. The source outlines some of their key duties, like keeping unauthorized folks out of the landing and takeoff zones.
And briefing passengers.
And very importantly, briefing passengers clearly on how to safely approach and board while rotors are turning.
Okay, so what are the key points for passengers in that situation?
There's a very specific list. Always stay away from the rear, the tail rotor area. Always crouch low.
Approach from the side.
Crouch from the side, within the pilot's view, unless it's a helicopter loaded from the rear, which requires extreme caution back there.
Carrying tools.
Carry tools horizontally, below waist level. Hold on to hats, loose articles. Never, ever reach for something if it blows away.
Protect eyes and ears.
Protect eyes from debris. Protect hearing from the noise. And a really important one, if you get blinded by dust or snow...
Stop.
Stop immediately. Crouch or sit down. Wait for help. Don't try to grope or feel your way around.
Good advice.
Yeah.
Now, since many helicopters don't have flight attendants...
So the pilot usually gives a safety briefing.
Right. Usually before takeoff, because of the noise. Our source lists the essential points. Seatbelts, doors.
Headset or intercom use. Safe entry-exit paths, always stressing away from the tail rotor. Stay in the pilot's view.
Securing loose items?
Securing personal items, yes, and also securing any front passenger flight controls if they're installed.
And specific briefings for certain flights. Over water.
Yes, for over water.
Yeah.
Location and use of flotation gear, survival vests, ditching procedures, how to exit in the water.
Rough terrain flights.
Location of maps, survival equipment.
And general emergency procedure.
Absolutely. Body position for impact usually upright, back against the seat. When and how to exit in an emergency. Location of the fire extinguisher.
Like PDRB.
And the EPIB, the emergency position indicating radio beacon, if equipped, and how to activate it.
That's a comprehensive briefing.
It needs to be. It ensures everyone on board knows the hazards and knows what to do routinely and in an emergency.
The source also makes a specific point about sloping ground operations.
Ah, yes. Always approach or depart on the downhill side.
To maximize rotor clearance from the ground.
Exactly. And if you have to walk around the helicopter on a slope, always go around the front. Never the rear near the tail rotor.
Okay. Now, let's touch on something the source strongly advises against. Pilots leaving the cockpit with the engine running and rotors turning.
The so-called quick turnarounds. Yeah, the source is very firm on this.
Because it's dangerous.
Extremely dangerous. An unexpected gust of wind, an accidental bump of the controls.
Would cause the rotor to hit the tail boom. Or the ground?
Exactly. Serious, potentially catastrophic consequences. The source really stresses that good practice, standard operating procedure, means pilots stay at the controls.
Whenever the engine is running and rotors are turning.
That's the baseline.
And if leaving is absolutely necessary, like maybe that refueling scenario we discussed.
It reiterates the procedure. Throttle to flight idle, all controls firmly frictioned. And only if the pilot is trained and proficient in doing that safely.
Right. Okay, finally. After the flight is done. After landing and securing.
The post-flight phase. Still important procedures here.
Includes parking safely, obviously. Not blocking other aircraft. Not posing a hazard.
Right. Choosing a good spot.
There's an interesting point about wind direction during landing. For counter-rotating blades.
Yeah, landing with the wind coming over the tail boom can sometimes help lift the main rotor blades slightly away from the boom as they slow down. A small technique.
The source also reminds pilots about rotor downwash, even after landing.
Still can damage nearby light aircraft.
Right.
And the danger turning rotors pose to anyone approaching, especially spectators who might not be aware.
And passengers. Stay put.
Absolutely. Passengers remain seated, seatbelts fastened until the rotors have completely stopped turning. No exception.
Then follow the shutdown checklist.
Always follow the manufacturer's checklist for shutdown, and then do a thorough post-flight inspection.
Look for anything unusual.
Note any discrepancies, any potential issues you notice during the flight or see now, And report them to maintenance if anything needs attention.
Okay, so just to recap quickly, we've covered a lot of ground, pardon the pun,
Right, nice one.
pre-flight checks, airworthiness, handling in-up equipment,
MEMLs versus the deferral rule.
rotor safety, which is huge for helicopters, refueling procedures, hot and cold.
And all the really vital safety stuff for passengers and ground personnel working around the aircraft.
And the common thread through all of this.
Is that fundamental pilot responsibility? The PIC's duty to ensure safety during every single ground operation.
It's a continuous thing, constant awareness, diligence.
Strict adherence to procedures and guidelines. It never stops.
This has been a really valuable deep dive, I think. Lots of critical details. So considering everything we've talked about today, all these ground safety factors, here's a final thought for our listeners.
Okay.
What single element do you personally believe contributes the most significantly to preventing helicopter accidents before a flight even begins?
That's a good one to ponder.
Definitely something to think about.
And, if listeners want to get into the real nitty-gritty of specific regulations or procedures we touched on,
Where should they look?
we'd strongly encourage consulting the FAA's relevant advisory circulars, like the AC 9167 we mentioned, and of course, always, always the rotorcraft flight manual for their specific helicopter.
That's where the definitive info is.
Absolutely, a wealth of essential detail in those documents.